Okay, guys, we are going to start preparing for our Unit 5. Well, hopefully you already started 2 days ago preparing for your Unit 5 systems. So I'm going to do a couple of each. I'm not doing all of them. I've sent out the answers through Remind 101, which can be, I'll also put them up um, before I end the video. I'll put up all the answers for a couple seconds. Give you a second, take a screenshot of it. So I'm going to work number 2. So number 2, I'm going to solve by substitution. So because I see that y is all by itself, so I would subtract 2x plus 2. And so this is going to go in place of the y right there. So whenever I do that, that would be also a minus 2. Careless mistakes. So I subtracted 2x and subtracted 2. Now remember, if you did not do it this way and you chose to do it a different way, then it still should work out as long as you don't make any careless mistakes. The way you don't make careless mistakes is by not being distracted, checking over your work, knowing how to deal with negatives and positives. And so I'm going to multiply this out. So this is 4x squared plus 4x plus 4x plus 4 and minus 8x minus 20. So then combining like terms. So this positive 8x and this 8x will cancel. 4 minus 20 is 16. And at that point, you can either solve for x or you can factor. I'm going to factor because that's really what, I don't know what I'm doing. There's a GCF. Okay, and then you have difference of perfect squares. So x is going to be positive 2 and x will be negative 2. So then to find the y value, you take your equation that you have up here, and I plug in x there, and you're going to get two different y values. So negative 4 minus 2. So that's 2, negative 6. And then negative 2 times negative 2 minus 2, 4 minus 2, so negative 2, 2. So these solutions could be, if you're talking about a linear and a quadratic, could be one solution, two solutions, or no solution. This is a quadratic, that's the top equation, and the second one is a linear one. Alright, so now I'm going to work, I think I'll work number 5. So number 5, we have, it actually happens to be either, it'll be two equations we've not covered yet, but we can solve it by elimination because we can see we're awful close to eliminating. So what I do is I just switch all of the signs in one of the equations. It absolutely doesn't matter which equation. I just pick the bottom one. So these cancel. You end up with negative 7x plus those cancel. 28 equals 0. Then you have a linear equation and you're solving for x. X equals 4. Pick either equation. Doesn't matter. So I'm going to take x and plug it in for x in both of the places. So I'm going to pick the top equation. It absolutely does not matter. Sorry for the delay. Okay, so then we have 16 plus y squared minus 48 minus 10y plus 32. So again, I plugged in my solution, which I found was x. I picked an equation, either equation, absolutely doesn't matter. So then I have y squared minus 10y. Looks like a 16 and a negative 48 and a positive 32 will actually all cancel. So then I factor out a GCF. Okay, because that's really the only way to, well, you could use the quadratic formula, but that might be more work. But if it's factorable, factor it. So y is going to be 0 and y is going to be 10. So that means we have the same x value for both y values. It's just coincidence. It just happens sometimes. There's no, I can't tell you when certain problems end up like that. Remember, you can always check all of your answers at the final, at the end if you wanted to. All right, so I'm going to go with, you know what? I'm going to go with number 7. So number 7 is probably a little harder than number 6. So number 7, we want to graph the linear one, so I'm going to subtract 2x. So my linear equation starts at 1, has a negative 2 slope. Make sure to plot as many points as you can. That's not right. Okay, then what I'm going to do, if you notice, the second equation isn't equal to y either. So I want to solve for y. So when I do, I'm going to put it in standard form. Remember last time my pencil kept breaking on me? All right, so that's in standard form. So since it's in standard form, I have to find the vertex using my formula, negative b over 2a, x equals. So when I plug in negative 2 for negative b, that becomes positive 2 over 2 times 1. That's the a, that's the what's in front of here. So that's going to be 1. That's my one of my vertex, my part of my vertex. So to find the y value of your vertex, you plug in 1 for x in the equation. So it's 1 minus 2 plus 3, y equals negative 1 plus 3, y equals 2. So I show on my work because you know what? Sometimes not showing all your work leads you to problems. So 1, 2 is my vertex. And then it's going up because the a is 1. And no matter what, oops, I use my 1, 3, 5. These two will not intersect because our linear equation is continuing to rise to the left, or I guess you could say fall to the right, and then our quadratic will continue to only change by 1 each time left and right. So this one has no solution. So again, quadratics and linears, when it's a quadratic and a linear, it's either 2, 1, or none. It cannot have infinite number solutions because they cannot exist the same place. I will not be working 8. It is quite a challenging problem. You would need the quadratic formula in the end or a calculator. I will go ahead and work number 10. So number 10 is like number 9. I will just take my x and my y and I plug it in for both. We can obviously see in the second one, negative 4 plus 4 is going to be 0. So that one's going to check out. So what I need to do is be very careful with negatives. It's the only reason you would miss a question, like this. So this is 16 times 2, so I'm not going to short it. I'm going to show all my work. 16 times 3, 7 times 4, and 12. So now I'll go back and work those. So that's 32, 48, plus 28, minus 12. Oops, sorry. And so whenever you simplify that out, then it does equal 0. So we would say, yes, it is a solution. So again, you can check every solution on these systems. Now, in order for them to work, it does have to work in all equations. All equations. You can't just check one, all of them. So, for instance, whenever we start, trying to see, So whenever we start say solving by substitution, what I want to do, I think I want to work 12. So on 12, sorry. What I want to do is I want to figure out either I'm going to substitute C into this equation, or B, what you would really want to do is you want to substitute B into the other two equations. The reason being is then you would have two equations with the same variables. If you substitute C into the second one, these two don't have the same variable. So in substitution, when you do the substituting, it has to happen in two equations. So this will be substituted for the B here and the B here. So it'll be C equals 2A minus negative 2A minus 10. So that's C equals 2A plus 2A plus 10. Silly little mistakes will lead to problems. So what I did is I got it set up for elimination. So once I simplified this side, I subtracted 4a. So then whenever I do the other equation over here, so that's negative, so that's this equation in for right there. So negative 6 times negative 2a minus 10 plus c equals 22. So 12a plus 60 plus c equals 22. 12a plus c equals, and I subtract 60 over because I want to get this ready for elimination. So I subtract 60 over and I get 38 negative. So what I want to do at this point is I want to eliminate, I want to put these two together, these two equations, and I want to eliminate a variable. And when I do that, then I'll have one answer. So I think by changing all the signs in this second equation to negative 12a minus c equals 38, technically I multiplied by negative 1, if you want to put it that way. Then the c's will cancel. I have negative 16a equals, see, look at that. Forgot my negative 38. So that's a negative. Did I do that right? See? Making sure signs are right is important. Oh, it was already a negative and I made it positive. Sorry. So it was negative 38. I changed all the signs so that it made a positive 38. So that should be 48. 38 plus 10. A equals negative 3. So then is there a place to put A for me to find another letter? Absolutely. There's a place right here that I can find B. So B equals negative 2 times negative 3 minus 10. 6 minus 10. B equals negative 4. And then is there a place to put C, or to find C? Absolutely. There's an equation that is ready for you to find C. C equals 2 times A minus B. So this is negative 6. Sorry, you can't see that. Negative 6 plus 4. So that's negative 2. So your final solution is A, negative 3, B, negative 4, C, negative 2. And remember, you can check all of your answers by plugging it into every equation. All right, so what I'm going to go back and do, I'm going to show you a quick picture of trying. Here is the front. You can see that. Trying to zoom out. Here is the front and the answers. So you can see, obviously, there's a variety of ways to work these problems. So there's not really just one set way. And so our answer is also down there too. So if we look at the second page, because I'm done with the second page, I'm not working 8, so there's no solution there, and then you can see that, okay, there's my solutions for those two. So, and again, variety of ways to work these, so if you don't see it my way, there's probably another way. So I'm going to work one elimination, and then I'll show you the answers for this page, and then I'm going to do some graphing and one of the word problems. Not going to continue all of it, but just one of the word problems, but I'll show you the complete answer. So with elimination, what you want to make sure to do is that you actually end up with 2 pairs of equations. So let me focus this. So what I'm going to do is I want to eliminate the same variable from the same 2 pairings. So for instance, I like eliminating the x's here. You could pick the y's, you could pick the z's, it doesn't matter. So what I'm going to do is I'm going to pair together the first and the third. Now obviously these don't cancel like that. The x's don't, but if I change all the signs to one of the equations, so I'm going to leave the top one alone. I'm going to change the signs in the second equation, or the last equation, to negative 4x plus 4y plus z equals positive 1. So if I'm going to eliminate the x's in this pairing, this next pairing over here, I have to eliminate the x's also. So why not use the same top equation, and I'm going to multiply this second one by negative 2, because I have to use that one. So negative 4x minus 6y plus 4z equals positive 54, I think. Alright, so now, when I do that, the same letters are canceled, eliminated. Then, what I have now is I have a new system, an easier system. I feel like I did something wrong. Nope. That actually works out well. Y equals negative 5. So it just so happens that when I made these pairings, one canceled. Now, what if one didn't what if not 2 canceled? Well, then I would have a system with 2 letters, and I would pair that system together. Let me show you what I'm talking about. Okay, so you can see, like, if it doesn't cancel, you take your 2 new equations and make a system out of it together. Obviously, I worked it different from the first time I worked it, and it's still going to work out fine. So then what I do is I take this negative 5, and I'm going to plug it right here. So negative 5 minus 3z equals negative 8, plus 5, negative 3z equals negative 3. Probably should show all my work. Z equals 1, and then you can take this and plug it into, I like the bottom equation maybe? So I need 4x minus 4, plugging it in here, times negative 5 minus 1 equals negative 1. 4x plus 20 minus 1 equals negative 1. Wow, I have 2 minuses here. 19. 4x plus 19 equals negative 1. 4x equals negative, oh gosh. I've messed up. Oh, silly, silly. Silly, silly. X equals negative 5. So you see, whenever I don't show my work, I tend to make those mistakes, and you can see that. Alright, so all the other methods, here, let me show you this page. I'll show you the bottom two. I did not work out the bottom two by hand, so you can see. Let me focus for you. Okay, so let me show you. I put the answers down on the bottom. Technically, you can solve these two by hand. It might be a good practice to solve these two by hand because on the test, you do not have a calculator that is able to solve systems. All right, so I'm going to work one of the graphing on the back and I'm going to start one of the word problems for you. I will not finish it for you. So right here, I'm going to solve for y. So I subtract x, so negative y. God bless. Divide by negative 1. And what happens here, if my pencil would stop, is that that inequality will flip around. Okay, so if I do this one, I subtract 8x, negative y. Divide by negative 1, it's got to flip around. Only by a negative. Only by a negative. So positive 4. Slope of 1. I'm graphing this one right here. I'm going to make sure that I make it a dashed line because it's not equal to. And I'm going to shade greater than, which is above the line. Okay, and then I have negative 3. Negative 3 with a slope of 8. Solid line because it's equal to. It's greater than. So it is above this line, but I don't really care to shade this. I just care that my shading is really dark where they overlap. Alright, so I'm going to do the number 22. So this one you will need graph paper. It is linear programming. It's the very last topic that we covered for this unit. So in order to solve linear programming, which is graphing with inequalities, you gotta graph it. So you will need graph paper to figure out how I got the solution in the end. So your question will tell you what you're trying to find. How much of each crop? Well, it talks about alfalfa and corn. And we have to state this because we know that it will not be below the x and the y axis. And then remember your equations have to have the same labels on the number. So for instance, it says corn requires 3 hours per ton and 2 hours for alfalfa. So 2x plus 3y is less, this pencil, less than or equal to the total hours. So it's got to be hours, hours, and hours is all in the same equation. So then if I was to graph this, it would be y is less than or equal to negative 2/3 x. And then, so I subtracted 2x and divided by 3. Uh-oh. I goofed. And I'm not starting over. I made a mistake. Okay, so let's see. Let's read through. Corn requires this much to harvest. This 500 is talking about the planting. So what happens when we have a farm? We plant and then we harvest. This 500 is the planting. This is the harvesting. So when I did that number, I goofed. So y is less than or equal to negative 2/3 x plus 400. Okay, so that would be what I graph. And then my other equation, this is my harvest. My planting equation, it takes each crop 1 hour. 1x plus 1y is less than or equal to 500. So that equation graphed out would be that. And then your profit, which is your objective, is 250x plus 350y. And so once you find your corners, I don't have the graph to show you. You should be able to graph this. I would maybe number by probably 10, no, probably 50 or 100. And so whenever you get it, your corners, um, okay, your corners meet up at these three places, and then this would be the maximum because once you plug it into your objective, the combination of 300 and 200 would maximize your profit. Okay, let me show you the rest of this page real quick. Okay, there's the top two. And there is the bottom two. Good luck. Make sure you show all your work on your test. See y'all tomorrow.